We tend to assume we sit at the absolute peak of human achievement. We carry supercomputers in our pockets and build machines that smash subatomic particles together at nearly the speed of light. That timeline gets complicated when you look at a discovery made by Greek sponge divers in 1901. Off the coast of Antikythera, they found a Roman shipwreck filled with statues and amphorae. Down in the wreckage, there was a calcified, heavily corroded lump of bronze. It was thrown into a box and sat in a museum for months. Then it cracked open. Inside were dozens of tiny, precision-cut bronze gears. Modern X-rays and CT scans eventually revealed that the divers had pulled a 2,000-year-old analog computer off the seafloor. The Antikythera Mechanism contained at least 30 interlocking gears. It was arranged in a complex system designed to predict solar and lunar eclipses, track the exact positions of the 5 known planets, and even mathematically model the irregular elliptical orbit of the moon. After this ship sank in 65 BC, humanity would not build another machine with this level of mechanical complexity for 14 centuries. It is the exact equivalent of finding a working laptop buried in a Viking mound. Finding this on a commercial cargo ship suggests it was being transported as a standard high-end product rather than a one-of-a-kind miracle. It represents a level of engineering that disappeared so completely that our modern labs are still struggling to decode how it was achieved. To figure out how our ancestors built these anomalies, researchers run them through top-tier diagnostic equipment. Take Damascus steel. Sometime in the early Middle Ages, Middle Eastern swordsmiths began producing blades capable of slicing a falling silk scarf clean in half, relying strictly on the fabric's own weight. You can identify these original blades by the distinctive swirling patterns on their surface that look like flowing water. In 2006, scientists put fragments of an original Damascus blade under an electron microscope. They found carbon nanotubes, cylindrical structures of carbon atoms arranged at the molecular level. They are among the strongest materials known to science. We discovered them in 1991, but 12th century blacksmiths were forging them into swords. That same microscopic manipulation shows up hundreds of years earlier. Roman glassmakers created the Lycurgus cup in the 4th century. It appears green in reflected light, but turns blood red when lit from behind. They achieved this by embedding gold and silver particles, exactly 50 nanometers in diameter, directly into the glass. We understand the physics of how light interacts with those metallic nanoparticles today. What we lack is the ability to recreate the process. Whether these molecular achievements happened through a quirk of medieval ores or deliberate engineering, reproducing them consistently remains completely out of reach. We spend billions every year maintaining concrete infrastructure because the material we mix today starts failing and exposing its rebar after about 50 years. Compare that to the Pantheon in Rome. Built in 125 AD, it holds the largest unreinforced concrete dome in the world. It has survived floods, earthquakes, and 2 millennia of weather without collapsing. For centuries, nobody knew why their harbors and aqueducts got stronger over time. Then, in 2023, MIT researchers found tiny white chunks of lime inside the Roman mixture called limeclasts. When cracks form and water seeps in, these clasts dissolve and recrystallize. The Roman concrete actively repairs itself when damaged. While the Romans were perfecting chemical mixtures, civilizations high in the Andes Mountains were achieving physical precision that defies our understanding of ancient tools. At Pumapunku in Bolivia, a temple complex sits nearly 13,000 feet above sea level. It features massive H-shaped interlocking blocks with perfectly flat surfaces and uniform drill holes accurate to fractions of a millimeter. They are carved from andesite and diorite, 2 of the hardest stones on Earth, by a civilization that possessed no iron or steel. Modern engineers admit they would struggle to replicate those cuts with today's machinery. These ancient architects were engineering lifespans and structural tolerances that embarrass modern civil engineering. Even with self-healing concrete, we at least have physical samples to analyze. Reverse engineering hits a hard wall when the original creator deliberately erased their blueprints. For nearly 800 years, the Byzantine Empire defended itself using Greek fire. It was a liquid incendiary projected through tubes mounted on the bows of ships. It ignited on contact with water and actively burned on the surface of the ocean, wiping out enemy fleets in minutes. The formula was the ultimate state secret. When the empire fell in 1453, it vanished. Modern chemists cannot recreate it because the historical accounts demand a liquid that could be sprayed through nozzles, ignite upon hitting water, stick to surfaces, and resist and be extinguished. From a chemistry standpoint, some of those properties actively contradict each other. That exact data barrier applies to ancient text as well. Sometime in the early 1400s, an unknown author wrote a 240-page manuscript detailing elaborate plumbing systems and completely unrecognizable plant species. The text follows consistent linguistic patterns, but World War II cryptographers, the NSA, and modern AI failed to decipher a single word of it. Having immense computational power doesn't help us when the fundamental logic of the technology is gone. The creators of these weapons and manuscripts took their operating systems to the grave. When you compile these artifacts, a specific pattern emerges. They force us to reconsider the narrative of human history. World-changing innovation is incredibly fragile. Damascus steel vanished when the specific ores used to forge it ran dry. Greek fire disappeared because it was guarded so fiercely that the empire died before passing it on. This chart shows the traditional view of human technological progress, a straight line moving constantly upward. But the physical evidence sitting in our museums disrupts that model. Knowledge peaks, collapses, and gets buried in the dirt for centuries. The ruins we pull from the earth demonstrate a mastery of chemistry and engineering that our own tools are only just beginning to confirm. We are effectively relearning a future that was already achieved and forgotten.